Welcome back to the Deep Dive, everybody. Today we're going to be talking about something that might seem pretty basic at first. We're talking about rational numbers.
Fractions, decimals, percentages, the gang's all here.
Yes, those things that we all use every day. But honestly, have you ever felt like fractions and decimals are basically speaking totally different mathematical languages?
I think a lot of people feel that way, yeah.
It's true.
Yeah.
And you're not alone if you feel that way. Get this. A recent study from NAEP, that big national assessment, found that
Half.
50%, a full half of eighth graders couldn't put three simple fractions in order from smallest to largest.
Wow,
That's a lot. It's a huge chunk of students. And it really kind of makes you step back and think, maybe we need to rethink how we're introducing these really important math concepts.
It's a fundamental problem, yeah.
Right. And that's exactly what we're going to dive into today. So for this deep dive, we're tackling a pretty core debate in math education. Should we teach fractions first, which is, kind of the traditional way it's been done forever, or should we actually start with decimals?
It seems like a simple question on the surface.
Yeah, just like which comes first.
Yeah.
But the research actually reveals some pretty fascinating stuff, some complexities about how our brains work, and honestly, it has some pretty big implications for how we all make sense of math, not just kids in school.
Absolutely.
So to guide us through this, we're turning to a really comprehensive review paper by Jing Tian and Robert S. Siegler. It was published in Educational Psychology Review back in 2018. And they basically did a massive deep dive themselves, looking at tons of research studies.
They've sifted through a lot of material to get to the bottom of this debate.
Exactly. So they're trying to figure out, are decimals actually easier than fractions? And if so, does teaching them first actually help students understand rational numbers better in the long run?
So we're going to follow their lead and dig into those questions.
Exactly. So let's jump right into the ring. What's the main argument in favor of teaching decimals before fractions? What's the logic behind this alternative approach?
Well, the big idea is that decimal notation is really similar to the whole number system that kids, typically learn first.
Right, like 1, 2, 3, 4.
Yeah. So researchers like DeWolf and his colleagues back in 2014, they pointed out that comparing decimals is easier because of this shared structure with integers, with whole numbers.
Right, like 10 is bigger than 5, so 0.10 is bigger than 0.05.
Exactly. And, going even further back, Johnson in 1956, so quite a while ago, noted that decimals basically use the same place value system as whole numbers, ones, tens, hundreds, thousands. So the thinking is that arithmetic operations with decimals might feel more intuitive to students compared to fractions.
Right, because fractions have those numerators and denominators.
Yeah, and they have their own set of rules.
Okay. I mean, that makes sense, right? You already know how to work with whole numbers.
Yeah.
And decimals, they just kind of extend that system with that decimal point.
Yeah, it does have a kind of intuitive appeal. You're connecting the new information to something that's already familiar.
Right. It's like building on what you already know.
But as Tian and Siegler point out in their review, this idea that decimals are just, quote unquote, easier, it actually faces some pretty big challenges when you dig a little deeper.
Okay, so there's more to it than meets the eye.
Definitely.
So where does this argument for decimals first start to break down? What are some of the counterpoints that these researchers highlight?
Well, one crucial concept is this idea of whole number bias.
Okay, what is that exactly?
So whole number bias is this tendency that we all have to sort of mistakenly apply the rules of whole numbers to other types of numbers. And this includes fractions and decimals.
Oh, so because we learn whole numbers first, we try to force fractions and decimals to fit into that same mold.
Yeah, exactly. We try to make them behave the same way. So some researchers, like Ganner Stern in 2013, thought that maybe decimals might actually help reduce this bias because they look a little different from whole numbers.
Okay, so the thinking is that the way a fraction looks, with the numerator and denominator, might make us think about two separate whole numbers instead of one single quantity.
Exactly.
But do decimals actually avoid that bias?
Well, that's the question. And Tian and Siegler actually present evidence that this whole number bias, it doesn't just go away with decimals. It's still there, lurking in the shadows. They talk about a very common error where students and even adults sometimes think that a longer decimal means a bigger number. So they might look at 0.123 and 0.45 and say that 0.123 is bigger because 123 is bigger than 45 as a whole number.
Right, because more digits means bigger number, at least when we're talking about whole numbers.
Exactly. But that's not how it works with decimals.
Oh, wow. So even with that decimal point, our brains can still default to those whole number habits that we learned early on.
Exactly. And the review goes on to say that many things that are true for whole numbers just aren't true for decimals. Like, for instance, decimals don't have a unique predecessor or successor. With whole numbers, there's only one number that comes before 5, and that's 4. But with
Hmm.
decimals, you could have 0.49, 0.499, 0.4999. You can keep going forever.
Right.
And the way decimals behave under multiplication and division is different too.
So even though the way they're written might look kind of like whole numbers, they actually behave really differently in math.
Exactly. And that kind of weakens the argument that just because decimals look similar to whole numbers, they're automatically easier to understand.
Okay, so it sounds like both fractions and decimals have their own unique challenges. Let's dig into some of those specific difficulties.
Hmm.
So when we talk about understanding the size of rational numbers, like actually understanding how big or small they are, how do fractions and decimals compare?
Well, understanding magnitude, how big a number is really important, and it's definitely a tricky area for both fractions and decimals.
Okay, so let's break it down. Let's start with fractions. What are some of the challenges kids face when trying to understand how big a fraction is?
With fractions, one of the biggest problems is that they have that numerator and denominator structure, and kids often treat them as two separate whole numbers instead of one value.
Right, like they see 12 as a 1 and a 2, not as a half.
Exactly. And this isn't just a problem for young kids. Research from way back in the 80s by Baer and colleagues, and then more recently by Siegler and Pike in 2013, shows that even older students often focus on just the numerator or just the denominator when they're trying to figure out how big a fraction is.
So like they might think 78 is smaller than 34 just because the 8 is bigger than the 4.
Exactly. They're not thinking about the relationship between the numerator and denominator, or they might look at 512 and 13 and think 512 is bigger because 5 is bigger than 1, and they're just completely ignoring the denominators.
Wow, so it's really easy to get tripped up by those fractions.
It really is. And decimals have their own set of magnitude problems. We already talked about that whole number rule, where longer decimals are seen as bigger.
Right.
But there's also something called the fraction rule that can mess kids up. And this comes from a kind of misunderstanding of place value. Like, kids might think that tenths are always bigger than hundredths because tenths are, a bigger unit.
Right, like a dime is bigger than a penny.
Exactly. So they might look at 0.47 and zero point 0.2 and say that zero point 0.2 is bigger because it's tenths instead of hundredths, even though 0.47 actually represents a bigger quantity.
So it sounds like both fractions and decimals have these built-in ways of tricking kids about how big they actually are.
Yeah, it's really interesting. And when researchers try to compare which is easier, fractions or decimals, for understanding magnitude, the results are kind of mixed. Some studies show that kids do a little better with decimals, at least in certain situations.
Okay, so maybe there's some support for that idea that decimals are easier, at least in some cases.
Yeah, maybe. But Tien and Siegler point out that a lot of those studies that found a decimal advantage were using decimals that all had the same number of digits after the decimal point.
Oh, interesting. So like comparing 0.75 to 0.25.
Exactly.
Yeah.
And when the decimals have the same number of digits, it's almost like comparing whole numbers.
Right, 75 versus 25. So in those cases, it's not surprising that kids would do better with decimals.
Right. But when you start using decimals with different numbers of digits, things get a lot more complicated. And there was actually a study by DeWolf and his colleagues in 2015 that found that kids were about equally accurate with fractions and decimals when the decimals had different numbers of digits.
Oh, so that changes things. It suggests that maybe decimals aren't inherently easier for understanding magnitude. It just depends on the types of decimals you're using.
Yeah, that's a really important point.
Okay, let's shift gears and talk about doing math with these rational numbers. Is it easier to add, subtract, multiply, and divide with decimals or with fractions?
Well, this is another area where things are pretty complex. Both fractions and decimals have their own unique sets of difficulties. And you see a lot of the same kinds of errors popping up with both.
Really?
Yeah. So with fraction arithmetic, a super common mistake is what researchers call the independent whole number error. Basically, this means that kids treat the numerator and denominator as separate whole numbers and just do the operation on them independently.
So like if you're adding 12 plus 13, they might just add the numerators and add the denominators and get 25.
Exactly. They're not thinking about the fractions as representing parts of a whole. And the crazy thing is, this kind of error sticks around. Research from the 80s by Silver and then more recently by Stigler and colleagues shows that even college students and adults who are training to be teachers sometimes make these mistakes.
Oh, wow. That's kind of scary.
Yeah. It shows how deep-rooted this whole number thinking is. And there are other errors specific to fraction arithmetic, like confusing the rules for different operations. For example, trying to find a common denominator when multiplying fractions. Siegler and Pike call these wrong fraction operation errors, and they're pretty common too.
So it sounds like fractions can really trip people up. What about decimals? Do they have their own set of arithmetic pitfalls?
Oh, absolutely. A big one with decimals is lining them up incorrectly when you're adding or subtracting. Kids often line up the rightmost digits, just like they would with whole numbers, which obviously leads to wrong answer.
Right, because the place values have to line up.
Exactly. And then with multiplication and division of decimals, figuring out where to put the decimal point in the answer is a huge problem. Kids might get the actual digits right, but then they put the decimal in the wrong place, and the answer is like way off.
Oh, yeah. I remember struggling with that in school. So it's not just about getting the numbers right. It's about understanding how the operation actually changes the size of the number, whether you're working with fractions or decimals.
Yeah, that's a great way to put it. And this is where this really interesting type of task called the direction of effects task comes in. Researchers ask kids to look at an inequality, like 3,144 times 2765 is greater than 3,144, and decide if it's true or false. But the trick is they're not allowed to actually do the calculation.
Oh, so they have to think about it conceptually.
Exactly. They have to figure out whether multiplying by a number less than 1 makes the original number bigger or smaller. And Siegler and Lordy Forbes found that both middle schoolers and even adults who are about to become teachers really struggled with these types of problems, both with fractions and with decimals. They often thought that multiplication always makes a number bigger and division always makes it smaller, which is of course not true when you're working with numbers less than 1.
Oh, so it's like they're overgeneralizing the rules of whole numbers again. That's really fascinating. It shows that the problem isn't just about fractions or decimals, it's about a deeper misunderstanding of how these operations work.
Exactly.
Okay, let's move on to another tricky concept. Density. Can you explain what density means when we're talking about rational numbers and how understanding it is different for fractions and decimals?
Sure. So density basically means that between any two rational numbers, there are infinitely many other rational numbers. You can always find another number in between, no matter how close together the two numbers are.
Right, you can always find the midpoint or divide the distance between them in half and then in half again and so on.
Exactly. But a lot of kids, even high schoolers, don't really get this. Studies by Vamvakusi and Wozniacki found that lots of ninth and 11th graders thought there were only a finite number of fractions or decimals between any two given numbers.
Wow, so even though you can keep finding more and more numbers in between, they think there's a limit.
Yeah, it's a really common misconception. And when you look at whether this idea of density is easier to understand with decimals or fractions, the research is kind of all over the place. Some studies suggest that 7th graders might understand it a little better with decimals, but by the time kids get to high school, there doesn't seem to be a big difference between the two. And even among adults, it's a tough concept. Tirosh and colleagues found that only a small number of pre-service teachers really understood the infinite density of both decimals and fractions.
So it sounds like density is just hard no matter how you slice it.
Seems that way, yeah.
Okay, what about translating between fractions and decimals? How good are kids at going back and forth between the two?
This is another area where a lot of kids struggle. They don't always see that fractions and decimals are just two different ways of writing the same number. Research by Vamvakusi and Wozniacki showed that a lot of kids think that between two decimals, you can only find other decimals, and between two fractions, you can only find other fractions.
Like they think they're two separate universes.
Exactly. And when you actually ask them to convert between fractions and decimals, they often make a lot of mistakes, especially when they're younger.
Yeah, that makes sense.
A study by Hybert and Wern found that 5th graders were really bad at translating between the two. And they even found that some kids were inventing these totally bizarre rules for converting fractions to decimals. There was this kid named Benny who had this consistent but totally wrong way of converting fractions to decimals based on adding the numerator and denominator.
Oh, wow. That's a great example of how kids can come up with these really creative but totally incorrect ways of understanding things when they don't have a solid foundation.
Exactly. And this problem with translating between fractions and decimals, it doesn't just go away when kids get older. Stigler and colleagues found that even community college students struggled to recognize equivalent forms of decimals and fractions.
So it's like they never really connect the two in a meaningful way.
It seems that way.
Okay, so we've talked a lot about fractions and decimals. What about percentages? Where do they fit into all of this? And are they easier or harder to understand than fractions and decimals?
Percentages are really interesting. The Tian and Siegler review actually points out that we don't know as much about how kids understand percentages compared to fractions and decimals, even though we use percentages all the time in everyday life.
Right, like sales at stores or interest rates.
Exactly. And kids usually don't learn about percentages formally until later, like maybe sixth grade or so, but they see them everywhere before that.
Yeah, those percent signs are pretty hard to miss.
Right. But even though kids see percentages a lot, their understanding is often pretty shaky. They seem to do okay with those really common percentages like 50%, 100%, and 25%. But when you get to less familiar percentages, they have more trouble.
So it's like they're memorizing those common ones but not really understand what they mean.
That could be part of it. And when it comes to actually doing math with percentages, like figuring out discounts or calculating tips, the accuracy is often really low, even among high school and college students. There were some older studies by Giller back in the 1940s that found incredibly high error rates on basic percentage problems.
Wow, so even though we use percentages all the time, we're not very good at working with them.
It seems that way. And here's another interesting parallel to fractions and decimals. Kids also have this misconception about what happens when you multiply by a percentage less than 100%. A lot of them think that multiplying by, say, 50% always makes a number bigger when in fact it makes it smaller. So again, it's like they're overgeneralizing rules from whole numbers.
Okay, so it sounds like fractions, decimals, and percentages all present very similar challenges for kids. They're all tricky in their own ways. So is there any hope? Is there anything we can do to help kids understand rational numbers better?
Well, there has been some interesting research on changing up when we teach these different forms of rational numbers. One really cool study by Moss and colleagues in the late 90s looked at teaching percentages and decimals before fractions, which is the opposite of what we usually do.
Oh, interesting. So they flipped the script, and what did they find?
They found that the kids who learned percentages and decimals first actually did better overall on rational number tasks compared to the kids who learned fractions first.
Wow, so maybe changing the order actually helps.
It's a really promising finding, but it's important to note that their curriculum also had other differences besides just the order of topics. They focused a lot on understanding magnitudes and connecting the concepts to things that kids already understood.
Right, so it's hard to say for sure if it was the order alone that made the difference.
Exactly, but it definitely suggests that the traditional way of teaching fractions first might not be the best way.
Okay, so after going through all this research, what's the bottom line? Are decimals really the easier starting point that some people think they are?
Well, based on this really thorough review by Tian and Siegler, it doesn't seem that decimals are inherently easier than fractions. Kids struggle with similar things across the board, whether it's understanding magnitude, doing arithmetic, grasping density, or converting between different forms. And those studies that found a decimal advantage, they often used very specific types of decimal problems that kids could solve using their whole number knowledge without really understanding decimals deeply.
Oh, so it's not that decimals are simpler, it's just that sometimes kids can get the right answer without actually understanding what's going on.
Exactly. And I think this review really highlights how much more research we need to do in this area. We need to understand more about how kids learn percentages, especially in comparison to fractions and decimals. And it would be great to have studies that look at all three forms of rational numbers in the same kids over time so we can see how their understanding develops. And we definitely need more research on how to help kids connect fractions, decimals, and percentages in a meaningful way.
So the question of which comes first, fractions or decimals, is still a very open question.
Definitely. And it might be that the starting point isn't the most important thing. Maybe the key is to help kids build a really strong foundation of understanding that connects all three forms of rational numbers.
Yeah, that makes a lot of sense.
And I think it's worth thinking about your own experiences with learning these concepts. What made sense to you? What was confusing? And what could teachers have done differently to make things clear?
Those are great questions for all of us to consider, no matter what age we are. Thanks for taking this deep dive with us today. It's been really illuminating.
My pleasure.
And for all of you listening, keep those questions in mind. And maybe the next time you see a fraction, a decimal, or a percentage, you'll see it in a whole new light.